Let's do some linear modeling. In this video, we're going to take a look at some real data and come up with some rate of changes and some linear models. We'll be using the slope-intercept form. We might also use the point-slope form as well. Let's go ahead and get right into the worksheet. The first example has some real data that I got from the Department of Health website. And we've got total cases of COVID in Chelan County from day one, the very first occurrence of a case, through day 150. First thing we want to do is to find the average rate of change over the entire data set. So to do that, rate of change average, it is the change in Y over the change in X, but this time X is representing days and Y is representing cases. So this is going to be the change in cases over the change in days. That distinction is important so that we can interpret this rate of change. When we're doing this, we want to go ahead and grab the first day and the last day. I'm going to call the last day 0.2 and the first day 0.1, and that's going to help us put this into our familiar slope formula, y2 minus y1, x2 minus x1. But in terms of cases and days, that's going to be the second case, so 1536 minus 1 divided by 150 minus 1. I can just do the math here. That's going to be 1535 divided by 149. Let's put this into the calculator. So 1535 divided by 149. And we get about 10.3. So this is about 10.3. 10.3 what? Cases per day. So over the course of the data set, the average increase in cases per day is 10.3. We can narrow this down though a little bit because we know that that rate of change is not going to be the same for each month. So this is broken down basically by month. So this is month 1, month 2, and so on. So we know it's not a consistent change. If we take a look at the data, we can see what this growth is actually doing. Let me get rid of this. And I'm also going to clear what I've got here. Let's just do this. Okay, so I want to go ahead and add this. I want to go click on the plus sign and then add table. And I'm going to go ahead and type in my days first. So 1, 30, 60, 90, hitting enter after each one, 120, then 150. I'm going to go up to the top of the Y column and type in my cases. 165, 176, 275, 656, and 1536. As I'm typing mine in, you can see on my graph that I've got all of the data values. You might not be able to see all of your data values, and that would be because of your graph settings. So let's click on graph settings. I'm just going to change mine -10 to 10, so just kind of a common viewing screen here. So if I change mine to -10 to 10, you can see that I can only see that first point. That's because I need my X's to go up to 150 and my Y's to go up to 1536. And there's no such thing as a negative day or a negative number of cases. So in your graph settings, you want your X-axis range to reflect what you've got. -10, it's nice to have a little bit of room below your data. So -10 is a good place to start, but we need to go up to 150. So let's go ahead and show the X's through 160. For the Y's, again, a little bit negative is fine, but I want to show the Y's up to 1536. So let's go up to 1600. Okay, now your graph will look like mine. Take a look, it's curved. It's actually exponential growth and it's concave up. This is a very, very common growth model for a virus. So as I'm looking at it, I don't really see that linear 10.3 showing up as a straight line between the first case and the last case. So I want to find where this is most linear, and that's definitely at the start here. I can see that I'm linear from day 1 to day 30, but then the slope changes and it's pretty consistent between this point, day 30, and this point, day 90. So I'm going to go ahead and choose this range, day 30 through 90. Let me go back over to the worksheet. Okay, so where is the data most linear? You could say 0 to 90, but really I want to grab where the data is linear with the same slope, and that's going to be these 60 to, or sorry, days 30 to 90. Okay, 30 to 90. I'm just going to express that as an interval. What is the average growth of cases during this time period? So I want to do a simple slope, and that is my average rate of change. For the data range, though, I'm going to go ahead and designate day 90 as point number 2 and day 30 as point number 1. So as I'm doing the average rate of change here, I'm going to take my second y, which is 275, my first, which is 65, so minus 65. Days is going to be 90 minus 30. And then if I want to put this in my calculator in a single computation, I want parentheses. Go ahead and clear what I've got here. And then parentheses 275 minus 65 divided by 90 minus 30. And we get 3.5. So this is equal to 3.5. 3.5 what? Cases per day. So over that time period, the increase was much lower. So 3.5 cases per day, that's going to go up here on my answer line. Cases per day. Okay, but still just doing slope there. Now we want to find the linear model. As I'm looking for a linear model, it means that my goal is really slope-intercept form. So my goal is y equals mx plus b. But I'm really doing cases. That's supposed to be a b. So I'm really doing cases and days. So it's going to be cases as a function of day is m times d plus b. Okay, let's go ahead and start to put everything together here. I'm just going to start by using my generic y equals mx plus b. I have m. M is that average rate of change. So I can write this as y equals 3.5x plus b. I've got too many variables, so I need to plug a point in and find b. So I can choose any of the points in that range. I'm going to choose that last one because I can see it, 90, 275. So as I put that in, y is 275 equals 3.5 times 90 plus b. Okay, so calculator, I need 3.5 times 90, and that's 315. So I really need to subtract 315 from both sides. That's going to give me a negative b. So back to my calculator here, I want 275 minus 315. And we get negative 40. So negative 40 equals b. Let me put that in green on the answer line and put it all together here. So b is negative 40. That's going to go here. I already have my 3.5, and I need to change my y into c and my x into d. So putting it all together, I've got c of d is equal to the slope or rate of change, 3.5, x, these are really days, so d, and then b, so minus 40. Okay, so there's my linear model for cases per day. Next, estimate the total cases on May 1st, which is day 45. So we want cases when D is equal to 45. Well, I have a formula for cases. Cases is equal to 3.5D minus 40. So C is equal to 3.5 times D times 45 minus 40. We can go ahead and put this into the calculator to get our answer. So 3.5 times 45 minus 40. And we end up with 117.5. So I'm just going to put that in green here, 117.5 cases. Okay, and then finally it says, how much did the cases grow in May? So I'm going to be using this growth model, days 45 through 76, live in this range. So I can go ahead and use my growth rate model. Okay, so I know that my rate during that time period is 3.5 cases per day. So I want to take 3.5 cases per day and multiply that times the number of days in May. 76 minus 45 is 31. So I'm going to multiply that by 31 days. Notice how days cancel, and I'm going to be left with a number of cases. So in my calculator, I want 31 times 3.5. And we end up with 108.5 cases. Green. Okay, so 108.5 cases. Okay, moving on. Number 2. So in number 2, we're given another set of data. And again, this is real data. I found it on the Labor and Industries website. I believe that was the website. Minimum wage in 2000 was $6.50. In 2020, the minimum wage is $13.50. Find a function for the minimum wage W in terms of the years since 2000 T. This is important. So we do want W of T, and normally it would be MX, but X is our T plus B. So this is our goal. I also need to do a little bit of translating here. So I have my year, and then I have T, and then I have the minimum wage. So let's go ahead and create a table for our data. In 2000, T is the years since 2000. Well, 0 years have gone by. Or this would be 2000 minus 2000. So this is going to be year minus 2000. My minimum wage at that point was $6.50. In 2020, so I want to do 2020 minus 2000. That's going to be 20 years has gone by. Minimum wage is $13.50. This gives me the 2 points that I want to work with. So there are my 2 points. I need to find M first. So step number 1 is to find M, the rate. And that's going to be, we'll call this point number 2 and point number 1. Okay, so it'd be Y2 minus Y1, but that's going to be our wages. So $13.50 minus $6.50 divided by, back to point number 2, 20 minus 0. So what is that? $13.50 minus $6.50 is $7 over 20. And I can go ahead and put this into my calculator. 7 divided by 20, I think it's going to be 35 cents. Equals 35 cents. 35 cents per year. So it seems like a big jump when we look at the entire time span, but linearly, the increase per year is only 35 cents. So not a huge increase per year. So this is 0.35. So 35 cents per year. 0.35, I forgot my decimal, 35 cents per year. Okay. Predict the minimum wage for the year 2030. So for the year 2030, first of all, I want to fix this so you can see it really well because we're going to use it. Oh, whoops. There we go. Okay, 35 cents, better. Predict the minimum wage for the year 30. So I've got my, oh, I didn't finish it, did I? So I need to finish it. I've got my rate. I'm so excited. Let's go back and finish this. Step number 2, I need to put a point in. Let's go ahead and choose 0,650, just because it's going to be a little bit easier to plug in. I want to put that into my goal here. So my wage is $6.50 equals M, which is 0.35, X or T, which is 0, plus B. So B is $6.50. Whenever we've got something in an initial year, this is always going to be B. Let's go ahead and write our answer down. I'm going to put it in red. Almost forgot to finish it. Okay, so here we go. W of t is equal to my rate of change, 0.35, times t plus b plus 650, that initial value, plus 650. Okay, now we can predict the minimum wage for the year 2030. For the year 2030, let's go ahead and put 2030 up here in our table. 30 years has gone by, and we're looking for that value there, so question mark. So let's put this together. I'm going to go back to my blue pen, and I'm going to go ahead and grab my function. W of t is 30 years, equals 0.35 times t times 30 plus b plus 650. So the wage after 30 years, or in the year 2030, is going to be, I can just put this into my calculator, 0.35 times 30 plus 650. And we get $17. Not bad. Okay, so $17. Okay, question number 3. In 2020, the average salary for a civil engineer is $93,816. In the year 2016, the salary is $89,730. At what rate is the average salary increasing? So my average rate of change is going to be the change in salary over the change in year. Salary, so let's do, I'll do the 2021 first. So 93,816 minus 89,730 divided by the years, 2020 minus the other year, which was 2016. Notice how for these, time almost always goes in the denominator, whether that's days or years. Okay, so parentheses around that numerator. So I've got 93,816 minus 89,730 divided by, I know that's 4 years. 1,021.50 cents. That'd be an increase per year. Get green. Okay, so again, it was 1,021.50. So increasing at a rate of 1,021.50 per year. If this trend continues, what will the average salary be in 2025? We didn't do any kind of an adjustment. We did put the year in when we did that calculation. So we can go ahead and put the year in, but in order to figure this out, oh, I know, let's do this. Let's do 2020. We're really going 5 more years, right? So we have 5 more years. This is a great way to do it. 5 more years. If I'm increasing 1,021.50 per year, I can multiply this by 5 more years. Grab my calculator. Let's see, the answer's already there. I'm just going to go times 5 equals, and I get 5,107.50. So this is going to be 5,107.50. That's going to be my increase. So I need to add this to, I was doing 5 more years since 2020. I'm going to add that to my 2020 salary, which is 93,816. So let's put that in. So that plus 93,816. Okay, so we just added 5 years of increase and we get 98,923.50. 98,923.50, assuming that consistent trend. And then finally, part C, find a function that represents the average salary as a function of years since 2016 T. So for this one, I want to go ahead and do that same adjustment that I had done in the last example. So I'm going to have the year, I'm going to have T, and I'm going to have the salary. I'm going to use the 2 points that I was given initially, or the 2 years. So we've got 2016, years since 2016. So in order to do that one, I need to do year minus 2016. Well, 2016 minus 2016, 0 years have gone by, and that salary was 89730. And in 2020, if I subtract that, I get 4 years, and that salary is 93,816. My rate of change is going to be the same. My goal, let me put that here because I'm actually just about there. My goal is the average salary, A, as a function of years, T. So A of T is going to equal M would be X, but in this case it's T plus B. I already have M. So A of T is equal to M, 1021.50. T, I just need to find B. Well, I've got myself an initial value. B is my y-intercept. And whenever I have 0 in for x, in this case it's t, this is my y-intercept, which means that this value right here is b. So I don't really have any more work to do. I can go ahead and write my answer here. A of t is equal to 1021.50 t plus b plus 89730. And we'll put a box around that.